This is Algebra 2 with trig. This is 7.4 through 7.1. This is the review. First, we're going to be working with graphing exponential. So we're going to pick values for x to determine what the y would be. So when x is 0, anytime you have a base with a 0 exponent, you're going to get 1. So 0 for the x, we're going to be up at 1. Watch your scale. When x is 1, you're going to get your base. When x is 2, you're going to get the square of your base. So you square the top and you square the bottom. So when x is 1, we're up at a quarter, and when x is 2, we're up at a 16th. And we're just getting closer to the x-axis, but it'll never reach it. When we're at negative 1, when an exponent is negative 1, we do the reciprocal. We do the reciprocal and square it. So when x is negative 1, we're up at 4. And at negative 2, we're at 10, 12, 14, 16 is actually just off the edge. So there is our exponential decay graph. And we know it's decay because it's dropping as x gets bigger. Your b value is less than 1 but greater than 0. Looking at this, we know our domain. What x values you can type in positives and negatives. So it's all real numbers for exponential graphs. The range, if you notice, it is going from the asymptote, which is y equals 0, and it's going up from that. So it's greater than 0. All the y values will always be greater than 0. It'll never reach 0. It'll never go below 0. When you graph these out, you like to write in your equation. The horizontal asymptote, right to left, we've decided that that was y equals 0. And your end behavior. As x approaches the left, as x gets smaller, the y value is getting bigger. The graph is going up. As x moves to the right, as x gets bigger, the y value is getting smaller, but it's not getting smaller all the way small forever. It's getting smaller, true, it'll always get smaller when x is bigger, but it'll never even reach the 0, let alone anything negative. So it's approaching 0. Here we have an a value and a b value. The b value is 4/3, so that means it's greater than 1. It's 1 1/3. So again, we're going to plug in x values. When an exponent is 0, we're going to get 1, but then we're going to times it by the 2. When it's 1, you're going to get your b value times 2 is 8/3. And when it is 2, you're going to get 16/9. You square both the top and the bottom. 16 times 2 is 32. So 32/9. When it's negative, you're going to flip it over. So it's 3/4 times 2, which is 6/4. And then negative 2, you're going to flip it and have 9/16, which is 18/16, because you times it by 2. All right, let's try to graph some of these. At 0, we're up at 2. At 1, we're at 2 2/3. Doesn't go up very far. This would be 3 with a few left over. Over here, this would be 1.5. This one is going to be 1 2/16. 1 1/8. Okay, so really that's going to keep heading up, and this will keep heading down until it gets close to the x-axis. So that is an exponential growth. Our domain, of course, is all real numbers. We can type in positives and negatives. Your range is going to be greater than or just greater than 0. The asymptote is at 0. The only time it changes is if there's a translation. As x goes to the left, the graph is approaching 0. And as x goes to the right, the graph is going up. Okay, this one does have a translation. So when we do this, we're actually going to be doing -3, 2 to the x. That's what our graph here is going to be. Our table. So we pick a value for x, which is 0, which makes 1, so we're at -3. When we pick 1, that gives us 2 times -3, which is -6. When it's a -1, it's going to be the reciprocal. It's going to be 1/2, 1/2. So it's -3/2. So we can look and see what that is in the, could you see those? In the graph over here. At 0, we're at -3. At 1, we're at -6. At -1, we're at 1.5. So we're coming down and we're slowly approaching the x-axis. So that is the graph y equals -3, 2 to the x. Now what we're going to do is notice that this says x plus 2. So if it says x plus 2, we're going to move it 2 to the left. So we're going to take every one of these points and move to the left. Doesn't look to have any k value, so it's not going up at all. It's still approaching that x-axis. Still has an asymptote right here at y equals 0. And the blue graph is y equals -3, 2 to the x plus 2. The horizontal asymptote we determined was y equals 0. The domain, it was all real numbers. The range was less than 0. That's where the blue graph was. As x approaches -infinity, the graph is approaching 0. And as x approaches positive infinity, the graph is going down. This one has a transformation. It has a translation. Translate 2 units left. So here, we're going to do the same idea on limiting this down to just the parent function. So we're going to do 1/3 to the x power. So we pick values for x. When it's 0, you get 1. When it's 1, you get the base. And when it's -1, you get the reciprocal. So we'll graph those. At -2, you'd be up at 9. So I like to graph those if they fit, just so I am following as most accurate as I can. So this is going to be the graph y equals 1/3 to the x power. Now we're going to take every one of those and we're going to translate it 2 to the left and 1 up. I said that backwards though. That's 2 to the right because it's a negative. It's 2 to the right and 1 up. So we go 2 to the right and 1 up, 2 to the right and 1 up. It's up a little bit higher. So now you have this horizontal asymptote at y equals 1. And your graph's going to be y equals 1/3 x minus 2 plus 1. We know the horizontal asymptote is going to be 1. The domain is all real numbers. The range is greater than 1. We know the end behavior. As x approaches the left, the graph is going up. And as x approaches the right, the graph is approaching 1. It's approaching the asymptote. It's approaching the k value. We're going to translate 2 units right because it's x minus 2 and 1 unit up because it's plus 1. The k value is 1. Okay, that's our first page. We'll end the video there. If you have questions, always let me know.